today's topic is going to be over combining like terms, which we will abbreviate as CLT. To start with, term of an expression is separated by addition and subtraction only. So down below you see 4 examples. The first one is just a single term. The second one, because it has one addition, has 2 terms, one on either side. The third one has a plus and a minus sign, so there are 3 terms on either side of those. The last example is a 4 term. So these have a specific name that we're going to ask y'all to know. If there is 1 term, the technical word for that is a monomial, meaning 1. If there are 2 terms, then like a bicycle, you're going to refer to this as a binomial. And I'm sure you can guess what we are going to call that which has 3 terms. And if you said trinomial, you would be correct. Okay. After the trinomial, if you look at this guy, he's got 4 terms. So if they have 4 terms or more than 4 terms, the generic phrase for that will be a polynomial. Okay. So within the terms, notice that there's multiplication. There could be division. So what makes them different terms is that there's a plus sign or a minus sign in between. Now the next thing that you're going to have to know is what the coefficient of the terms are. So coefficient means it's the number multiplied by the variable in a term. So for instance, if you study these 4 examples, we have one monomial, 10x. The coefficient of this term is 10. If you look at the next one, we have another monomial, and its coefficient is a negative 8. This term is also a monomial, but we have to ask ourselves what number is being multiplied by the variable. And if there's nothing there, really we're going to treat this as 1. So the coefficient of this y is 1. And I would put some stars by that. I would put some exclamation points by that, because that's one that's you have to remember. Right? The last example we're looking at is a binomial, and it has 2 terms, therefore we have to identify 2 different coefficients. So for the first term, we have a coefficient of 6, and the second term, we have a coefficient of negative 4. So that takes us to our next thing that we have to talk about, which is this. And if you need to pause to copy down this sentence, please do. If you are subtracting a term, the coefficient is negative. Okay? So if you are subtracting a term, the coefficient is negative. So in this example, we subtracted 4x, which is why we said the coefficient of x was a negative 4. Now for this next part, we're going to call this do now number 1. And I would like you to put a big old triangle around the number 1 part. And what I would like you to do is to identify the coefficients of each term that you see below. Okay, so what is the coefficient of each of these terms? And your expression is negative 8 times z to the 4th power plus 3z cubed minus 6z squared minus 5z. So you have 1, 2, 3, 4 terms, and I would like you to tell me what the coefficient of each of the terms is. For this first term, the coefficient is a negative 8. The second term is a 3. The third term is a negative 6. Because remember, anytime I'm subtracting a term, the coefficient is negative. So just as this is a negative 6, the last one has a coefficient of negative 5. Okay, so to be like terms, by definition, like terms have the same variable parts raised to the same powers. So I will show you a couple of examples here. And if you look at how these are organized, in this first column I have 3 terms that I would consider to be like terms. I have a negative 12y, a 4y, and this one of course we know is really a 1y. These would be different than if I had terms that included x and y. So this column is all like terms because they have the same variable parts. This last column is still different than the first column because even though they both used y, in the third column it is being raised to the power of 2, and in the first column it's really being raised to the power of 1. So like terms must have the same variable parts and the same powers. So only these are able to be combined, only these are able to be combined, and because these are like terms, we can combine them. If you look at this final set of numbers, we would refer to these as constant terms, which are terms that have no variables in them. So constant terms are just numbers, and they form a like term category of their own. So to combine like terms, the process is this. You first have to add the coefficients of the like terms. Then you have to keep the variable parts exactly the same. So add the coefficients of the like terms, don't change the variable part of it. So if we look at these directions to combine like terms using the previous columns that we had created, I will show you how to get them down to one term only. So if these 3 are like terms, it says we're going to add the coefficient of the terms. So I would be adding a negative 12, a 4, and remember this is a 1. So if I add 5 plus a negative 12, you're going to end up with a negative 7. And we keep the variable part exactly the same. So when I combine like terms here, I created a negative 7y. If you look at the middle column, xy is all the same terms. So I combine their coefficients, and an 8 minus 2 is 6 plus 9. In the end, you have created 15xy. Notice I've only added their coefficients, and I kept the back half exactly the same. Likewise, this last column here, I have negative 4 and a negative 5. That makes negative 9 plus 9. Those two cancel out. And when I have 0 times anything, I just created 0. So all 3 of these terms just created nothing. On your own, I would like you to copy down this next example. And we're going to call this do now number 2 and put a big old cloud around it. Okay? So your directions for do now number 2 are to combine like terms. And then you have a 1, 2, 3, 4 term expression that we'll call a polynomial. So take a moment, combine like terms, and you should have gotten this. 6j squared. When I combined these j's with these j's, a negative 10 plus a 2 is a negative 8j, and then the 5 at the end. Okay? So that, when I combine like terms, becomes the trinomial 6j squared minus 8j plus 5. Okay? The second one is negative 12 plus 6x plus 4. You have a trinomial, and I have to combine the like terms. And in this case, only the constants are able to be combined. So I can combine a negative 12 with a positive 4 to make 6x minus 8. We cannot combine variable terms with constant terms, so in the end, this trinomial became this binomial. So you may have been asking yourself if you had ordered these terms differently, if it's still correct, and that leads us to the next and final part of our lesson, which is how you're to order terms in what's called standard form. So if you look at how I ordered this first one, I put the higher powers first, and those constants are at the end. Just like in B, the constant -8 was at the very end. So to order polynomials in what's called standard form, there's a couple of different steps that you have to do. The first is that you have to make sure that your coefficients go before your variables. The second is that you're going to rearrange the terms by putting highest powers first. And then you have to be sure that if the terms have the exact same power, then you're going to put them in alphabetical order. And always, those constant terms are at the end of your expression. Okay. Here we have an example of how to order this trinomial in standard form. So I look and I have an exponent of 2, so that's going to be at the very, very front. But anytime that I change the order of an expression, I have to use the commutative property, and the commutative property applies only to addition. So another way to look at this is subtracting 2x squared is really adding a -2x squared. This is still positive, and that 10 at the front is negative. So if I am to move them using the commutative property of addition, because this is a power of 2, I'm going to put that term at the front of my expression. And then I'm going to put the 5x, which has a power of 1, and lastly, my -10 goes at the end of my expression because it is a constant term. So I've taken this trinomial and put it into standard form. So the last thing that I'm going to have you do today is do now number 3. And you are going to put the expression that you see here in standard form. What you should have done is put the -2y squared at the front of your polynomial. And then you have y's at the front and at the back of your expression. So when you combine them, you can put them together first, like so, and then the x's here, and then the constants like so. So there are two things that are remaining to make this standard form. One is that we have to combine the 8y and the 2y because that's combining like terms. And the other thing that you may notice is that I put the y's before the x's. So I have to put the highest power first, and then I'm going to put the x term before my 10y, and lastly my constant 4 goes at the end. So in simplified standard form, you end up with this polynomial.